Greetings, everybody. So this talk is not about word nets. It's about a practical tool, practical device of a different form, different nature. But something that is very useful in the work of linguists, especially when preparing texts in which many numbers have to be written out in words. Such a thing can happen for all kinds of reasons. So, for example, when working on a reference grammar, a research paper, a presentation, something like that, a problem on number names for a contest in a kind of text portion, which is uncommonly difficult for a human mind to process for some reason. And at the same time, at least typically, we know that computers are good at processing numbers, working with numbers. So, as I said, it is a good idea to leave this part of the effort to the system. The human effort, in this case, is of course not reduced to zero. It is concentrated on composing a grammar which describes the feature of the number system in the language, but the bulk of the typing and the proofreading is done for us automatically. TeX does it. TeX is actually a text processing system, a text generating system, but typesetting with TeX is akin to writing a program in several ways. First, because it relies on designing macros using macro definitions. Those are control sequences which can be evoked anytime they're needed, and they can produce mathematical formulae, words, sentences, whole text passages if need be, so that we have to do less typing, fewer keystrokes, fewer typos, fewer inconsistencies. We can use variables, registers, and we can store information of various types in it, chunks of text, numeric values on which we can perform operations on, in particular, integer arithmetics. And also the language, which is TeX, has flow of control constructions, flow of control structures, if then else, switch type, so depending on the outcome of a numeric comparison or of another Boolean construction, we do something. Depending on the non-negative integer value of some variable, we do something. So we are kind of write a program which produces the text. In this talk, when I mention TeX, I don't necessarily mean pure TeX nowadays. LaTeX 2 epsilon are used much more frequently, or other extensions, but the core is the same. The core is shared. And the things that we use here are the same. Why do these, I allow myself a few words on the inspiration. There were several inspirations for this idea. In fact, one of them, or maybe the major one, or one of the major ones, was a short passage from the TeX book by Donald Knuth, the creator of TeX, which you see here. He explains how TeX can be used to produce the sentence, the first 30 prime numbers are 2, 3, 5, 7, and so on. And then he goes on to say that he did not actually type them in. So the sentence was produced automatically by writing just what is written in the center of the screen. The first 30 prime numbers are, and then it turns to a macro, primes 30, which means write the first 30 prime numbers. So the macro is responsible for calculating the numbers and typesetting them in a sentence, or putting a comma between each two successive numbers, putting an n before the last. And also the fact that TeX can write a thing in two ways in a sequence. So for example, in Arab TeX, a package, an extension on TeX for writing text in Arabic, which was designed with my modest participation back in the 1990s, at a time when typing in text in Arabic script, or basically anything else than plain ASCII Roman, was difficult. Arab TeX was designed in order to enable typesetting in Arabic. So the idea is that you would write your text in transliteration, in Roman letters with a few additional conventions, carets, dots, hyphens, and so on, and you would get your text in Arabic, or you could get a transliteration of the Arabic, or for that matter, you could get the two things side by side. So you write a thing in transliteration, as I said, following those conventions, and you get the Arabic text in the traditional script plus a Roman transliteration next to it. So if this can be done, why not take advantage of the same idea and have the computer write a number in Arabic numerals and in words in whatever language you choose? Especially because we know that computers are good at solving this kind of problem. Many courses in programming, many books of collections of problems for computer programmers contain this kind of exercise. This is just one example taken from a book. It's originally a French book, but I had the Russian translation, so I took it out of there. An exercise which says, write a program in this case in Fortran 4, a language that's actually very, very badly suited for this kind of thing. So write a program which is going to produce the numbers of from 1 to 100 in French. And the program has to actually implement the rules which are listed down there. So let's do the same thing when we are writing a text with numbers in it. How difficult this is going to be depends on the feature of the number system. So here are a few features which tend to make a difference. It depends on what the base of the number system is and whether there are supplementary bases, or sometimes the bases. For example, you can have a system base 10, but 5 plays an auxiliary part. Are there alternative names of the base, other numbers that plays a Bay-like part? What arithmetic operations are used in the formation of number names? So addition and multiplication are virtually always there, but subtraction may play a role or not. Overcounting may do so or not. What operations are marked? Is the order ascending or descending? Are there any changes in the derivation of number names, phonological changes? So for example, we say Bulgarian has a decimal number system. Multiplication expressed by juxtaposition. Addition is marked either by the preposition na or the conjunction I, depending on whether we are below 20 or over 20. And there's a bit of a phonology because the numbers 1 or 2 can participate in their forms for the neuter or the masculine gender. So what we need is write essentially one big macro. We want to have a macro that's simply going to be invoked as a BLG, Bulgarian 42, to produce something like 42. And what it does is it splits the number into tens and ones and turns in the auxiliary macro boolean, which use numerals in the range 1 to 9. So this is boolean, which produces a number between 1 and 9, taking into account the fact that the 1 is masculine or neuter and the 2 are likewise. And the big macro turns to that and produces the whole thing. So having these at the thing on the previous page, we can generate all numbers in Bulgarian from 1 to 99. And it goes up from there. Well, Biram is a language which is spoken in Nigeria, the Atlantic Congo family. It's an especially good one for implementing this system on because it's written with many diacritics in Roman script. So the danger of making a typo is very high. Otherwise, it is very similar to Bulgarian. It's different in a few things. It's duodecimal system, base 12. So instead of saying that, say, 52 is 5 times 10 plus 2, it is actually 4 times 12 plus 4. But on the whole, what you do is pretty much the same. Subtraction is used. So 9 is literally called 12 minus 3, for example, and there are a tone change that has to be accounted for. So things are a little more complicated on the surface, but in fact, the macro is very similar to the Bulgarian one. So this is a part of a text generated with the use of our macros. This is what you get at the end. So see very many words, difficult to type words with many diacritics, as I said, and each of them is only typed once. So we're guaranteed against making typos, writing the same thing over and over again. I'm not going to dwell in much detail on other examples. Yoruba is more interesting because of the way it's organized, or the number system is organized in a different way. There it uses subtraction a lot, many times. So it's base 20, but if you have an odd number of tens, they're expressed as the number of 20 is minus 10, for example. So things are rather more complicated in terms of the mathematics that goes into it there. Still, the macro on the whole looks like the ones that we looked at. And this is a part of a text. The upper half of this slide is what you write in the source, and the bottom is what is generated. They say YORL 3, and what you get at the end of 3 eta. You say YORL 135, and what you get is 135 Aron Din Orgon Edge. The language, the language Umbu Ungu from Papua New Guinea is base 24, and 4 is a secondary base. So you have to divide the number by 4 to see how many 4s it contains. If it's an integer number of 4s, then you have to say see how many 24s it contains. And a number of multiples of 4 have special names, which has to be listed. And also it uses overcounting. So it means that if you have a number that is not divisible by 4, it's actually an integer number of 4s that you are moving towards. So for example, 57 is called 1 towards 60. That is to say 1 from the 4 which completes 60. It starts at 56. In fact, what this means is that you have to check if the number of 1s is 0, and if not, you add 1 to the number of 4s before generating their name. And the last thing I want to mention is, that is to say, test case, last actual case that we dealt with using this system for the language Sulka, Papua New Guinea. Again, it has 3 number systems for counting coconut, for counting breadfruit, and for everything else. And so to generate the name of a number, you have first to account for what it is you're counting. And you have to choose the appropriate number system. And also you have to put the noun in the appropriate grammatical form, which means singular or dual or plural. They're often suppletive. And what this means, in fact, the take-home story of this is that you get to expand the method beyond the numeral. So you don't stop at generating number names, you get to generating entire noun phrases containing numerals. So why this is interesting? Well, because it is, in fact, a blend of text processing writing computer program and automatic natural language generation of a lightweight type. Oh, thanks for your attention.
Any questions? Questions from the people which are online, who are online, sorry. Okay, I have one question. Have you thought about using this for applications, for example, for text normalization, for, let's say, text-to-speech applications? It could be a very good thing.
It could, yes. It could be interesting. I haven't thought about it as of now.
That's what I thought while I was looking, besides linguistic problems.
It could have potential.
Okay, thank you. Any other questions? Let's thank our speaker again.